Hi everyone, I am Dr. Kavitha. Today we are going to see recurrence formula for Pn of x. That means the Legendre's equation. The following recurrence formulae can be easily derived from the generating function for Pn of x. Here I am giving you on 1, 2, 3, 4, 5 recurrence formulas. The first one we have to derive first. Now we prove the first one. Let us take the equation that is called as the legendary polynomial. The legendary polynomial equation. This one we have completed in our previous lecture. This equation we can taken as equation 1 and differentiate it partially with respect to t. This is legendary polynomial equation for generating function. So that legendary polynomial equation for generating function we can differentiate partially with respect to t means we get this equation. On simplifying that we find the equation on equating the coefficient of t power n from both sides we get this recurrence relation. Okay. Finally, after simplifying, we get that the first recurrence equation what we have given here in this. Okay. The next second one we need to prove now. The second recurrence formula x pn of x equal to x pn dash of x minus pn minus 1 dash of x. Again, we are taking that same legendary polynomial equation. Let that one has equation 1. Differentiate partially with respect to x now. In the previous one, we differentiate partially with respect to t, but here we differentiate partially with respect to x. On differentiating, we get this equation 2. Again, differentiating partially with respect to t, we have this equation 3. On dividing 3 by 2, we get the equation after getting into the form of the second recurrence formula. After equating the coefficient of t power n on both sides, we get that second recurrence formula. The third recurrence formula we need to prove now. The third recurrence formula, we know that the recurrence formula, the first one, the first recurrence formula we have taken now. On differentiating the first recurrence formula with respect to x, we get the equation 2. From that equation 2, we know the another recurrence formula, formula 2, recurrence formula 2. From that we find the x pn dash of x. Let that as equation 3. This is second recurrence formula. From that we find this. Let this as equation 3. Now on subtracting 3 into, we obtain the equation that is called the third recurrence formula. And now the fourth recurrence formula. In fourth recurrence formula, we know the recurrence. Again, we are taken the first recurrence formula to derive the fourth one. Differentiate the first recurrence formula with respect to x, we get this equation. And now on simplifying here, on taken the pn of x as common and here pn dash of x. Now this is an pn of x. Now pn dash of pn plus 1 dash of x, here n plus 1. So on equating both sides, replacing n by n minus 1, we get pn dash of x is equal to x into Pn dash of x, Pn minus 1 dash of x plus n Pn minus 1 of x. That is fourth recurrence formula. And one more recurrence formula we have, I think so, right? The next one, how we needed to prove the equations 2n plus 1 into 1 minus x square Pn dash of x equal to n into n plus 1 of Pn minus 1 of x minus Pn plus 1 of x. So now again we are taking the first recurrence formula. In first recurrence formula we derive this Pn of x minus Pn plus 1 of x. Here taken n as common. We get n into Pn minus 1 of x minus x into Pn of x. And from this first equation, we find the equation 1 and equation 2 and 3. From the first one, from the first recurrence formula, we find these three equations. And using these three equations, we derive this. Here we substitute this x into Pn of n of x minus Pn plus 1 of x. Okay, so here n into Pn minus 1 of x, x into Pn of x as 1 minus x square Pn dash of x. Here from equation 1 we get this. Okay, so from equation 1 we get this. Again from equation 2 and 3 we get this. And from equation 2 and 3 we substitute the x Pn of x in the left hand side, x Pn of x. From equation 3 you substitute here, and x Pn plus 1 of x, that one here we have. Okay, from the equation 2. And now on substituting and replacing we find this equation. Now I think Pn dash of x we remove from that. Now we get the final equation what we needed to prove. Okay, next in our next lecture, actually this is my lecture 11, series solutions, legendary polynomials, recurrence formulas. Here we have proved 5 recurrence formulas. How can we derive from legendary polynomial equation? Okay, so let us see in the next lecture. Thank you very much for listening. Thank you. These are the recurrence formula for generating function for Pn. Okay, so we will see in the next lecture. Thank you very much. Thank you. See you. Bye.